Hello, a very good day, students. One more time, I'm here, myself Sharad Gupta, and welcome you all for a chemistry class, chemistry with Sharad Gupta. Today, student, we will learn the next method of expressing concentration. Today, we will learn about molality and molarity, right? Both are wonderful methods for expressing concentration. Molality is a method of expressing concentration where we take mole of solute divided by mass of solvent in kilogram. Yes, student. Molality is expressed as a small m. Small m stands for molality, and in this we are depending only on the mass of solute as well as the mass of solvent here. The mass of solute is converted into mole and the mass of solvent is taken into kilogram. Why I am insisting again and again here that molality is using at both the places mass only, because mass is a physical property which is free from the temperature variance. So it means that in molality, the number which comes out here, which is calculated out here, will be free from any kind of temperature variation. So molality does not depend on any change in temperature. We will be having another discussion on the dependence of molality on temperature. If we again try to solve this formula, students, so molality, which is equal to mole of solute, so mole of any solute can be calculated out by taking that mass of solute in grams divided by molar mass of solute in gram per mole. So this comes out to be the mole of solute divided by mass of solvent in kilogram, which is WA. For example, student, if we have 2 grams of glucose, right? So 2 gram of glucose can be converted into moles here. So in place of WB we will write here 2 grams, and in place of MB we will write here 180 gram per mole. So 2 divided by 180 will be the mole of solute here. Whatever is the mass of solvent, that shall be converted into kilogram. The solvent must be in kilogram. So WA, the mass of solvent, is taken in kilogram. In this way, the unit of molality comes out to be mole per kg here, right? Molality is also expressed as small m. So wherever it's mentioned that the solution's molality is 1 m, right, it means that that solution's molality is 1 mole per kg. If it is mentioned as 2 m, that means the solution's molality is 2 mole per kg. So small m is used as a unit for expressing molality here. The next method for expressing concentration is molarity. Yes, R-I-T-Y, molarity, right? Molarity is expressed as capital M, and this is the mole of solute divided by volume of solution. Yes, student, here we are using volume of solution, and that also in liter. So in molarity, the volume factor is coming in. So it means molarity does depend on temperature. As the temperature will change, the volume also changes. So molarity is a temperature dependence method of expressing concentration. We will discuss it one more time. Mole of any solute, as you know, that can be calculated out as mass in gram of that solute, WB, divided by molar mass of that solute as MB, divided by volume of solution in liter, that will be the molarity. The unit of molarity is mole of solute divided by volume in liter. So hence mole per liter, or capital M is the method by which molarity of any solution is expressed. For example, if we have 1 m solution of anything, that means the solution's molarity is 1 mole per liter. Suppose a solution's molarity is 0.25 capital M solution. That means the solution's molarity is 0.25 mole per liter. That means in 1 liter of solution, 0.25 mole of solute is present. Right? Yes, student, after learning this definition and formula of molality and molarity, please try to solve these problem. In the first case, in example 1, 2.5 gram of CH3COOH is dissolved in 75 gram of benzene. I repeat, 2.5 gram of CH3COOH ethanoic acid is dissolved in 75 grams of benzene. Here you have to find out the molality. You are given here molar mass of CH3COOH is equal to 60 gram per mole. In the next case, you are given here in example 2, 1 mole of KCl is present in 1 kg of water. And here you have to find molality of the solution. I repeat, 1 mole of KCl is present in 1 kg of water and you have to find molality of the solution. In the third case is given, student, in example third here, that 30% CCl4 solution is in benzene. Means benzene and CCl4 are mixed together and the solution's concentration is given 30% weight by weight, right? And you are asked here to determine the mole fraction of CCl4, mole fraction of benzene and the molality of the solution. In all these three examples, you have to calculate out yourself. You can pause the video for 1 or 2 minutes, solve it and see that whether your solutions are matching to the answer given or not. In the first case, which was given here, 2.5 grams of ethanoic acid is dissolved in 75 grams of benzene. So as you can see, student, solvent is benzene and solute is ethanoic acid. And who told me? As you know that as per the definition, the solute is in lesser quantity and the solvent is in higher quantity. So whatever is in lesser quantity, I am taking it as a solute, and whatever is in higher quantity, I am taking as a solvent. The mass of solvent as per the formula is supposed to be in kilogram. So we are taking this 75 gram as 75 into 10 raised to minus 3 kilogram here. Okay. The molar mass of CH3COOH was given as 60. So the first thing we calculated out here, mole of solute of ethanoic acid, which is 2.5 divided by 60, mass in gram divided by molar mass, is equal to 0.041 mole. Now, as per the formula of molality, mole of solute divided by mass of solvent in kilogram. So here mole of solute is 0.041 and the mass of solvent is 75 into 10 raised to minus 3 kilogram. It comes out to be 0.546 mole per kg, which you can also mention as 0.546 small m mole per kg. In the second formula, it was given 1 mole of KCl in 1 kg of water. So student, it was very easy because mole of solute is already given 1 and the mass of solvent is also given as 1 kg. So 1 mole divided by 1 kg. So molality comes out to be 1 small m, or you can say as 1 mole per kg. Student, the third example, which I believe you all have done it correct, you can check with this solution here. It is 30% CCl4 and CCl6 and you are supposed to find mole fraction of solute and solvent both here. So what we do here, we assume that let the solution is equal to 100 gram. If your solution is 100 gram, that means 30% of that is CCl4 and the remaining is the solvent. So CCl4 is 30 gram and the solvent is 70 gram. The number of moles of CCl4 is mass in gram of the solute divided by molar mass of CCl4, which we have calculated out here. CCl4 means mass of carbon plus 4 times of the mass of chlorine here. So 12 plus 35.5 into 4, that comes out to be 12 plus 142 is equal to 154 gram per mole. So we have put here this 30 divided by 154 is equal to 0.194 mole of the NCCl4. Similarly, the number of moles of benzene could be found out 70 grams divided by 78 gram per mole, the molar mass of benzene. So which comes out to be here 0.897 mole. Now to find out the mole fraction of XCCl4, the mole fraction of carbon tetrachloride is equal to mole of carbon tetrachloride divided by total number of moles present in the solution, which is NCCl4 plus NC6H6. So the values 0.194 and divided by 0.194 plus 0.897, both are being added, and on solving you get the mole fraction of carbon tetrachloride as 0.177. But student, in this question you are also asked to calculate mole fraction of benzene. So you have two methods now. Either you can solve like this, that in place of XCCl4 you write X benzene and write here N benzene divided by total number of moles and you calculate out. Another method is that since two components are present in the solution and mole fraction of one is known, so you know that mole fraction of two component system, if mole fractions are added, it comes out to be 1, means XCCl4 plus XC6H6 is equal to 1. And if you know the mole fraction of 1, you can calculate out the mole fraction of other substance. So here XC6H6 is 1 minus 0.177, so it is equal to 0.823, right? So we have just calculated mole fraction of XCCl4, and with the help of that we have calculated out mole fraction of benzene also by subtracting out of 1. So solution in the student, in the example third, you were asked to calculate molality also. In this case 30% CCl4 is present in benzene, and we did calculate mole fraction in the previous screen. Now we are going to calculate molality. 30% CCl4 means CCl4 is 30 gram and benzene is 70 gram. So mole of CCl4 can be calculated as 30 divided by 154. 30 is the mass in gram and 154 is the molecular mass, the molar mass of CCl4. And 70 gram of benzene is taken as a solvent, but we have to convert it into kilogram. So 70 into 10 raised to minus 3 kilogram here. By solving 30 upon 154, you get the number 0.194 divided by 70 into 10 raised to minus 3, and this comes out to be 2.77 mole per kg, which can also be mentioned as 2.77 small m. Right student, so this is all for today. Hope you have enjoyed the class here and all the examples of molality and mole fraction given here. In the next class we will discuss some more example based on molarity. Till then, keep watching the video and keep enjoying learning chemistry with Sharad Gupta. All the best to all of you. God bless you all. Thank you very much.